Hey guys, Math Unlocked, and today we'll be learning about infinite geometric sequences in series. More importantly, how to sum up an infinite geometric sequence. I have a couple example problems for you, then I'll have some practice problems for you guys to try at the end of the video. So let's get started. Alright, so looking at this first problem, we have 256, 64, 16, and 4. So the first thing we want to do is find out what the first number in this sequence is. So our first number, or A1, is equal to, right here, 256. Alright, so the next thing we need to find is the common ratio. So the common ratio, well, to get from 256 to 64 and 64 to 16, you have to divide by 4, and 16 divided by 4 is equal to 4. So you have to divide by 4 to get to the next number, but you can't really plug that into our equation that we're going to use right here. So what we are going to do instead is multiply by 1/4, which is the same thing as dividing by 4. So our common ratio is going to be 1/4. Alright, so now using this equation to find the sum, we take A1, so 256, then divide that by 1 minus 1/4. Alright, so now with that, we get 256 over 3 divided by 4, and then we can simplify that to 341.33 repeating. And that's our answer for this problem of 341 and 1/3. Alright, looking at this problem, we have 1,248. So we need to find our A1 value and our R value. Alright, so our A1 value is this first term right here, so 1,000, alright? So now the R value, so to get from 40 to 80, you have to divide by 5. Then 20 to 40, you also have to divide by 5. And 1,000 to 200, divide by 5. So it's going to be 1/5 for our ratio. Alright, so now we can plug everything into this equation, and we get 1,000 over 1 minus 1/5. Now, 1 minus 1/5 is 4/5. So, 4 over 5. Alright, so then it's going to be 1,000 over 4 over 5. And if we take 1,000 divided by 4 over 5, we get 1,250. Alright, and that's our answer for this infinite sum. Alright, so looking at this sequence, you can notice it's just a little bit different from the other ones. This one is getting increasingly bigger and bigger. Alright, so now if we have an equation like this, our R value is going to be, well, in this case, 2. But since this is getting bigger and bigger, we're multiplying by 2, we'll get 64, then 128, and then 256, and it's just going to keep getting bigger from there. So we're not going to be able to calculate the sum of this, so the sum we can just say is infinite, and that will be our answer for this problem. Alright, here we have some sigma notation. Alright, so now referring down to this equation right below, we get our A1 value, which is equal to, in this case, 3. Alright, then we can get our R value, which is equal to 1/2. Now, with this sigma notation, we can notice that we go from our first number to an infinite number of terms. So this is an infinite sum. Alright, so now we take our A1 value, which is going to be 3. Now we take that over 1 minus R, which is going to be 1/2. So then we get 1 minus 1/2, which is going to be 1/2. So we get 3 divided by 1/2. So now to solve this, we can multiply the top or we can multiply by the reciprocal of this function on the bottom. So we'll get 3 times 2 over 1. And this is just equal to 6. So our answer for this problem is 6. Alright, so now let's get into the practice problems. Alright, here I have 4 practice problems for you guys to do. I'll have the answers in the description. If you have any questions, feel free to ask them in the comments below and I'll get back to you. But thanks for watching and have a good day.